Okay, today I'm going to talk to you about static electricity. So before we know about static electricity, just a little reminder about atomic structure. So in an atom, if we remember, we have in the nucleus we have protons and neutrons, which remember protons are positive and neutrons are neutral, and around the outside we have electrons. Now this is important when we're thinking about static electricity, because when you rub two insulating materials together, that is an insulating material is something that does not conduct electricity. When we rub two insulating materials together, electrons are transferred from one thing to another. Only ever are electrons transferred. The protons and neutrons, because they're in the nucleus here, they are never transferred. It's only ever electrons that are transferred during static electricity. So let's imagine this. Let's imagine I've got a balloon and I've rubbed the balloon against this person's hair. So as you rub these two insulating materials together, electrons are transferred from one way to the other, from one material to the other. So the balloon, because the electrons have been transferred this way, has become negatively charged, and this person's hair has become positively charged. The reason why the hair has become positively charged is because it's lost these negative electrons. It hasn't lost any protons, it's only lost electrons, so now it's positively charged. So this is why, if I was to zoom in onto a couple of strands of her hair right now, this person's hair, I'd see that they were both positively charged because they've lost electrons. Now comes for the next important piece of information. If we've got two things of the same charge, they will always repel each other. Whereas if we have two things of the opposite charge, they will attract each other. And this is a really important part of static electricity. So if we go back to thinking about this person's hair, which is now positively charged, if this was two strands of her hair, we could see that they would repel each other and try and get away from each other as best they can. This is why after you have statically charged her hair, it will stand up like this, because each hair is trying to repel the other one, or is repelling the other one. So that is how static electricity works in this particular case. Let's see another example. So let's imagine I've got my negatively charged balloon. Negatively charged, remember, because it's had loads of electrons transferred into it, because we've rubbed these two insulating materials together. And I start to bring this balloon close to this wall. So the wall, the wall is made of matter, so it contains protons, neutrons and electrons, because it contains atoms. It's made up of atoms. So what happens is, as we start to bring the balloon closer to the wall, these electrons in the surface of the wall are repelled, because we've got the negative electrons in this balloon. This negatively charged balloon is going to repel these electrons. This means, because all these electrons have now left the surface of the wall now is positively charged. This means that if we bring this balloon even closer to the wall, it is in fact going to stick to the wall, because we have the positively charged wall being attracted to the negatively charged balloon. So that's how we can actually induce a charge. Okay, the next thing we need to know about is earthing. So sometimes, now apologies for my picture of a car, this is not going to be the greatest car ever. So sometimes you can, your car can get charged, can get statically charged. So it could be the rubbing of your clothes against the seats, that kind of thing. And so as a result, your car could get a certain charge. Now, this could potentially be dangerous because if you went to refuel your car, there could be a sudden discharge of this static charge, and the electrons could suddenly flow out of the car, causing a spark. And if it was in a petrol station, it could cause an explosion. So as a result, objects need to be earthed. So certain objects need to be earthed. Now what this means is some cars can have this little wire at the back that connects to the ground. So often it's made of copper, as long as it's a conductor that connects it to the ground or to the earth. And so this charge can flow out and not build up. So by earthing this car, we're not going to create a spark by a sudden discharge of this negative charge, and instead it can flow out through the conductor and into the ground. The reason why the charge can flow directly through the wheels is that the wheels are made of rubber, and therefore they are insulators, so electricity can't flow through it. So just to go over the main points, static electricity is when electrons are transferred when two insulating materials are rubbed together. The object that the electrons are transferred to becomes negative. The object that the electrons are transferred from becomes positive. Remember, there's loads of phenomena that they could talk about in an exam, which are to do with either attraction between oppositely charged things or repulsion. And also what earthing is when we connect a charged object to the ground using a conductor so the charge can flow out and we don't have a sudden discharge and potentially an explosion. Thank you.